And what we plan on talking about today is a quick intro to the Nmap Scripting Engine, or NSE. We're going to talk about the difference between vulnerability scripts and discovery scripts. So the CyberScope brings in a new concept to scripts and how we leverage them inside of Nmap that is really powerful and really useful. We'll take a look at how do we load these scripts onto the CyberScope, how we get them onto the devices, and then how you can share it across teammates' devices as well. And we're also going to talk about executing scripts as a one-off test versus an auto test. Like, what are those differences between this? How do I actually leverage Nmap? Because those of you that have seen the CyberScope, you've probably seen that there's an Nmap icon on it that you can run, but we also want to talk more importantly about how do we use these things in workflows, which is where all this really starts to shine and where it starts to excel. This particular webinar is building off of a bunch of other, actually I should say a bunch. We've got 3 other blogs that we've got up there on the cybersecurity blogs, and you can find those at cyberscope.netally.com/blog. But if you take the /blog off, you're going to end up at the CyberScope home, which is kind of where we're putting all of our cybersecurity stuff around the NetAlly product lines, CyberScope, and we've got some other blogs out there as well around just vulnerability assessments. One of the first ones that we did was just talking about, why vulnerability assessments are important. And we'll kind of go over some of those details real quick here too, as this quick intro. And then we also introduced the Nmap Scripting Engine and also building custom NSE and discovery scripts. One of the scripts that we're going to be looking at here during the webinar is actually up on the blog. So I'm going to jump out of the slides here real quick and bring up a browser so you can see this here on this. This is a good thing to have handy even during the webinar here, so that you can kind of see it. I'm going to do my best to zoom in on the text so that you can see what it is that I'm looking at, but we all know that that doesn't necessarily come across perfectly through webinars. So I do have this posted up here under the building custom NSE and discovery scripts. You can see the text of one of them that we're going to work with if you want to look at it a little bit more closely and have it so that you can actually see it a little bit more clearly on your screen directly in there. But we're going to go through and we're going to talk about all of that here in just a few. But I do encourage you to go back and check these out, especially the importance of vulnerability assessments, because this is a new area that we're kind of going into here with the cybersecurity, and cybersecurity today is extremely important. Just yesterday I was reading about Microsoft finally figured out how one of their attacks happened where some of their key information was out there. And when we look at security and look at cybersecurity, we so much focus on the human element of it, that, somebody was social engineered or somebody had a phishing attack, something happened with that through the vulnerability assessments, that route. But we still need to look at our devices. Yes, the majority of attacks are coming from social engineering, phishing attacks, or credential leaks through commits into any type of repository, Git or Bitbucket, whatever you leverage. Yeah, that's where some attacks are coming from. But it's still important to look at your devices and understand your endpoints and understand how your firewall rules are set up. For a long time there, the marketing buzzword was zero trust network. And we had, we don't have to worry about firewalls because everything's in the public cloud. So they're secured from that way. We've got socket layer connections that are secured. And we kind of started focusing away from endpoint security and focusing more on application security and visibility through whatever services you're accessing. But endpoint security still is a large part of vulnerability assessments and figuring out this proactive versus this reactive concept of how do we look at our network and how can I be assured that we are secure? Because I'll be honest, it's not a question of, if you're going to be compromised. It's the question of when you're going to be compromised. How do you react to that? And what can you do to try to limit the impact of that attack that's happening there? So again, we got all this stuff that's up here on cyberscope.netally.com. We also put the link to that in the announcements there so that you can just click on it to get up into it. But I definitely recommend bookmarking this link so that you can get all the information about the blogs, our next webinar that will be coming up as well here. And we got some white papers and everything up in there that'll help you out through kind of taking a look at this from our viewpoint of what we see as importance with cybersecurity and vulnerability assessments, not just entirely geared towards the CyberScope, but just also looking at it as what's going to happen overall in the cyber environment. So good place to look at. And like I said, bookmark that and check it out for some of the resources. All right, with that quick intro on there, let's dive into and let's talk about what I really want to talk about, which is vulnerability assessments with Nmap Scripting Engine, and then ultimately deploying that onto a CyberScope and how we kind of simplify this process and go through. I'll be honest up front, this is going to be quite technical up front, because if you've never looked at the Nmap Scripting Engine, this might look crazy to you. It might look bizarre and be completely foreign, but we're here to talk through this. If you have questions, like Brad said at the beginning, put the questions into the platform, and the BrightTalk platform, and Brad will interrupt me if we need to go over it verbally. Otherwise, he might try to answer it, or he might say, hey, we got to take that offline, and I'll provide you with our email addresses afterwards at the end of this, so that you can also feel free to contact us, and we'll get those questions answered as best as we can. So hopefully all of you are familiar with Nmap, but if you're not, Nmap is a platform that can be installed onto most all devices out there, Windows, Mac, Linux-based machines. And the purpose of Nmap is to try to figure out the what about a device, the what about an endpoint that's on your network, some sort of connected device. Okay? And Nmap is great because it's very powerful, and there's lots of different things that we can do with it. But that also comes at a little bit of an issue as well, though, is if something is extremely powerful, it usually ends up being extremely complex. And we have all sorts of different switches and everything that we have to work through to try to figure out how do we actually leverage this program to understand what it is. So if I'm on my command line and I just look at this and say, show me what Nmap can do, nmap-help, I look through all this, that's a lot of different scripts that I got to figure out. What about this? What if I want to know about a particular device, my network? Like, let's say, for example, I want to know about my Apple laptop. Well, how do I know what scripts I want to run at it? And if you're in the security arena of doing vulnerability assessments, it's not so much about just blindly going out there and running an attack against a device and trying to figure out what's out there. You should have some sense of, this is what I want to look for. This is something that I care about. I care about these services. I care about these actions. And that's one of the things that we actually talked about in the blog post that we put up there, is that you need to have a goal in mind when you're doing this. You don't just look at it and say, okay, let's sit down and let's start doing this. I use this expression a lot when I talk about things. You sit down at an empty typewriter or empty keyboard with a blank page and you start just rambling off words. Who knows if it's going to become a cohesive document at the end of it? We need to figure out, okay, what do we want that outline to look like? What are we trying to actually go for? And what's that service that I'm looking at? As an example, in the blog post that we had out there is, I want to go through and I want to look at and I want to figure out things about the browser, the web server on that computer, because I might know that there was a new flaw that was introduced in certain versions of the Apache software that's running on it, or the Nginx, which are different server applications that can run on their computer to be able to serve up websites. So I know these because I might have looked at like CVEs, the common vulnerabilities and exploits, and I understand that there's new ones that were released. So I'm going to try to cater Nmap, and I want to try to confine it into what I actually want to look at to understand what's going on through this, instead of just blindly saying, all right, let's run, and I'm going to run their example here just because it's really easy to do if I can type, nmap.org. So I'm just saying I want the version number. I want to just look at this as OS detection of what's on scanme.org. So it's going to go through and it's going to run some scan. It's going to try to figure out what some ports are that are open on there. And what it's looking for is it's trying to compile this data to come up with a fingerprint that says, this device is Mac OS, this device is Windows, this device is Linux, whatever it is. It's trying to look at all these different things that it can do. And through this action, it's going to come up with eventually something that comes back and says, okay, here you go. Here's what I saw. I see that the host is up. I see that it's got quite a few closed TCP ports, which is good. That's what we want to see. But by the way, there's some of these open ports, one of them being port 22, which is SSH. And I can see that the version string that I got off of it from that is OpenSSH 661p1 Ubuntu. Now, that might not necessarily mean anything to you, but to an attacker, that's something that is extremely important, because I could look at it and say is that if I know that there's a vulnerability inside of OpenSSH 6.6.1p1 on Ubuntu, I could flag something inside of one of my NSE scripts that I'm going to write here that we're going to look at in just a second. And I can say, if I see that, You know, that's something that I should add to a list of hosts that I want to do some more thorough investigations on. I might want to attack it with some other type of script that actually is going to try to compromise that device. It's actually going to do something to it. I can see I got port 80, which is HTTP, so it is running a web server. So if I were to go to scanme.nmap.org, something's going to show up in a browser. I've got an nping echo open, and I've got this random port here open, TCP wrapped. If you actually look at the port number, this is Nmap being funny from back in hacker speak days. The 31337 is elite, so their elite port is open. They play some games just to be able to see that you got some different ports that are up in there. And we went through all this, and we saw that it ran the scan on it, looked to see what ports were open, and it came back with some data. Now, if I was somebody that was doing a pen test against your network and I saw this, like I said, I'm going to start to act on these ports by somehow, because I see that SSH is open and I see that port 80 is open. Those are two fairly common ports that are open on devices, because again, the port 80 is a web server port, so that's pretty standard. But that gives me an into that box, because if I connect to that device on that port, it's going to give me some data. And if I can maybe push some parameters to it through query strings, maybe there's something that I can do to that box. Maybe I can cause some sort of overflow somewhere. I can cause a memory buffer run. I can cause something that would enable me to get further access into that device. And that's the goal of somebody that's doing an attack on a network, is they scan to figure out where the holes are, and then they try to figure out how to compromise said holes. So when you're doing vulnerability assessments, you're going to be doing the exact same thing, where you're going to be scanning your devices on your network. You're going to be coming up with a list of devices that have certain ports open, and then you're going to figure that out. Now, if I were to do this scan, and I did this scan against, let's say, Brad's laptop, and this same data came back where I saw SSH was open on it, and I saw that port 80 was open it, Brad and I would probably be having a conversation, because I'd probably be asking them, hey, Brad, why do you have SSH enabled on your laptop? And if Brad comes back to me and says, well, I don't, then I know that somebody's put something on Brad's laptop, and this could be something that's used for like a command and control and a botnet. So I leverage these ports by looking at them and figuring out that, okay, just because it says that it's a common one, I have to look at and figure out whose device it's on as well. If it's on a server and it's expected to be open, that kind of changes my thought process around how I do my assessments of that device and figure out what the risk is of having that port on. But if it's something like it's Brad's laptop, and I know that he shouldn't have SSH on it, he shouldn't have a web server on his, then I start asking those questions as to, okay, why do you have those on there? So as another example here, if we run this same one, but let's just run it against a device in my network, which, make sure that one's still up. Yes, it is. So this I would consider is just a compute device. Okay, it's just a typical device. It could be an endpoint on it. In my case, it is a Raspberry Pi that's sitting on my network here. And I look at this, and you can see I got the same information that SSH is open on that. So as it just being a standard network device, I would kind of question why you got SSH running on it. But you see here I have port 8000 open, which is HTTP. And this right here is the type of server that is. So if I looked up at the previous results that I got, see on this port 80, it didn't tell me what it was. There was no signature that was returned by the web server. So this is kind of nice in that I can't figure out, I don't know what's running that web server. I don't know if it's Nginx or if it's Apache, what it is. So I have to, I'm kind of limiting my scope here, where I have to do some further digging to figure out how I could attack that thing to try to get into it. Whereas on this particular Raspberry Pi that I have here, I'm not too happy about this, because it tells me exactly what it is. It's a Node.js Express framework. So by it telling me that it's a Node.js Express framework, I can look at that and say, oh, now I know what I need to do. I need to go and look at any Node.js vulnerabilities. And by looking at those vulnerabilities, I can figure out how I can get into this, if there's anything I can do. And another thing that you see that's interesting here is that it's also giving me an HTTP title. So this thing actually gave back a browser window. Okay, so by actually getting it back on there, that I see this is called Bitfocus Companion. that gives me even further information about figuring out what I could do to try to attack that, because now I could go look at that and say, okay, yeah, let's go in here and let's say, what is bit focus, right? And if I look at bit focus, okay, bit focus is companion. It's a small team of creators. All right. Well, in this particular case, what this application is this is my switcher. So if I bring this up here on 8000, I use this to control my camera inputs on webinars. So yes, this is running a Node.js web application, Bitfocus Companion. But because of the fact that it kind of leaked, this is what we talk about where in vulnerability assessments, it's leaking information on us. By leaking all this information through here, we got so much information about this device to be able to go look at and start figuring out, how do I attack this thing? How do I get into this box? What can I do to this? You know, and it even tells you what all the supported methods are in here. You know, we have everything that we need right in this block to figure out how to compromise this device, if that's possible. Okay. So by looking at Nmap, we get all this information, and Nmap is great for this. And like I said, it's very powerful to use, but this doesn't necessarily help me when I'm trying to work with the team or work with a lot of folks on trying to figure out a full vulnerability assessment, because if either side of the fence that I'm on, whether it's the good side or the bad side, it's all about time. And it's all about trying to automate this process. You know, I don't want to go through here and say, okay, that was 180. So what's on 181? What's on 182, 83, 84, 85, etc. We want to be able to figure out, how can I automate some of this process, and how can I come up with these results and this the attack information to try to do a full pen testing, if you will, of an environment. And that's where Nmap Scripting Engine, or NSE, comes into play. So Nmap Scripting Engine, I'm not going to go through doc verbatim in here or anything. I'm going to focus more on actually showing you some scripts here, but I just wanted to show this real quick to you. Again, all this stuff is linked to off of our cyberscope.netally.com in there. But Nmap Scripting Engine is really powerful. What it is it's based off of the Lua scripting language. And Lua is just a lightweight scripting programming language. It's not too complex. You know, those of you that maybe have done programming way in the past, and you think about, oh, I need to associate, you know, I need to do like malloc if you did C programming or anything like that. No, it's similar to like a Python style scripting language, where it's extremely lightweight. It's very easy to read and very easy to go through and figure out, you know, what it is that you're trying to do, just with pretty common language terms of trying to figure out what it is that we want to look at. But there's some important things about scripts and the NSE scripts that I want to talk about real quick, that I do want to look at the web page for and show you this. And that's these script types and script categories, okay? And again, I'm not going to read through all of this, but we'll expand it up so you can see it a little bit better on here. What's important about these script categories is that when you write a script, even if it's just for your own personal use, you're still going to put it into some kind of category. And that defines what the script does and what the risk is associated with running it. You know, some of these things, like you see here, brute. These scripts are going to use brute attacks to try to guess an authentication credentials. Something that is a brute, that could be something that could bring down networks, because you're constantly hammering some service trying to do something. So we need to be careful about running things with brute. Same things with running when we start looking down later on here, where we've got DOS or exploits. DOS is a denial of service. Exploit is where you're actually going to try to actively exploit something. And by running this, it could potentially bring down network, bring down a device. So as you look at your scripts that you're going through, or as you're looking at all the scripts inside of NSE that are installed when you put Nmap onto your machine, it's important to look at what the script category is first, before you just say, hey, I want to blindly run this on a /24 at my network, at my work, because I hope you're going to get noticed by security ops, because they should notice that somebody is doing port scanning on your network. And B, that might be what we call a resume generated event if you bring down your corporate network because you're trying to do something that actually does an exploit. So we have to be cautious about the scripts, and we have to make sure that we're looking at what the category is so that we don't inadvertently bring down our network. Okay. And then there's some other ones that are like safe. A couple of scripts that we're going to show you here, they're marked as safe because they're not really doing anything against the network necessarily. They're just going to query into some other information to get through it. So look through those and understand the different types that you have in there. And then the script types themselves is about how does this actually run. One of the nice things about NSE scripts is that they don't actually have to necessarily run against a specific target. We can actually just use this as a way to run generic tests, which is what we are going to do in one of our script examples. It's actually not ran against a host. It's just ran because we have this tool, this Nmap software that allows us to run these scripts that we can bring additional information into our discovery results, for example, or things like that. So you look at the different types. We've got host rules, host scripts that are ran against an actual host, a port script, which is against a specific port. So that would be like the port 80 when we want to attack the web server and figure out if we can get through it in there. So you'll want to look through these and kind of see how they're going through it. But let's dive into an actual script here, and let's talk about the components of a script and then how we execute them and everything in there. So first, real quick, before I get into there, we have this in the blog post, but you need to know where those scripts are, okay? So by default on Linux and on Mac OS, this is where they get installed to. It's the /user/local/share/nmap/scripts. Yes, that's a mouthful. I understand that it's a mouthful. There is a flag that we can do to say script dir or the data dir to be able to say where it is. I'm not going to go into that in too much depth on that, but that is inside those NSE docs that you can look at it. Again, what I want to talk about is the actual script formats in here. So we need to know where those scripts are. So I know where those scripts are here. So I've placed a couple scripts in here. I've got two of them that we're going to look at. We're going to look at one that goes out into and queries some information from public service to be able to look at, figure out what my IP information is and my ASN, things like that. And then we're also going to look at one that queries specific devices in my unified network at home here to be able to get some more data points onto that. So let's look at this. So first thing I'm going to do real quick is I'm just going to run the script. I just like to show you what it is that we're doing. So the first one is this script IP info IP API. So all I'm doing is I'm saying nmap-sc-script and what the script name is. The script file name actually has a .nse on it, but we don't need to put that in there when we're running through scripts. We just leave that off. So I go through here and I say this and I hit enter, and it's going to start running nmap just like what it did. In this case, this is what's called a pre-scan script type. So this actually doesn't require any host. It doesn't require a port. It doesn't require anything. It's just a script that's being ran. So it just triggers off immediately. And in this case, it comes back with what the IP, my network, my ASN, my org, and my location are of my ISP. Okay, behave. Don't start DOSing my IP address, please. I'm hopefully that everybody will be respectful in there, and I'm not blurring things out here because I want to make sure that you see what the data is that's actually coming back on there. So if I actually look at this Nmap script, and I have my code window open up here, you can see these are all the NSE scripts that are there. So one of the things I tell folks constantly when we're looking at NSE scripts is that if you're trying to come up with a new script, first look to see if there is a script that does what you want it to do. Second, look to see if there's a script that does sort of what it is that you're looking for and kind of build off of that. So in my case, I wanted to use this IP API. I knew that there was a couple things out there that were doing some of these geolocation IP infos, but they require different services with different API keys, things like that in there. So I wanted to create my own, very simple. I don't have a lot of error checking in this. I'll be honest, there's actually one error in the Unify script that I purposely left in there just so that we could speak about how some of these scripts need to be wrote and what you need to do to take into consideration how the CyberScope specifically is going to execute these scripts versus you executing these scripts just on your laptop with Nmap. So what it is that we're looking at here in this script here is that this is my IP info, my IP API. And at the top of it here, I start off by saying I need to use some Lua libraries. So libraries are things that others have wrote where they've pulled some of the common functionality out so that you don't have to keep rewriting the same code over and over and over again. So in my case, I want to use the HTTP library, which is going to enable me to do HTTP calls, just like as if I were sitting at a web browser and I went and typed in the address. This allows that script to do it. JSON is because I'm getting a JSON JavaScript object notation object back from my API. So that's that data structure of the format in there. Oops is about raising error messages. Like I said, these things are pretty commonly named, so it's pretty easy to understand what's going on there. Standard NSE is just a few common functions that the Nmap creators and NSE creators put together for us to be able to leverage. And then table, because I want that to be in a nice table output. So for me to get that table output that we have in here where it looks like this, that's a table, because these are different table rows and table columns in there, okay? I give it some kind of description of what it is that this is supposed to do. And I define and show what the usage is, what I expect the output to be. These dashes mean that they're comments, so they're not actually executed in there, okay? The description, I have it where it's bracket, 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 just means anything inside here is just text that's going inside of this description, so that when I format it into the code docs or anything, that's in there. You know, who wrote this, what its license is, and here's those categories that we were talking about. It's a discovery, external, and it's safe. And I code it this way because, well, first of all, it's safe in that it's not actually doing anything that could attack or bring down any network. It's just querying in a service. It's querying an external API service, so that's why it's external, and it's discovering additional information for me. So you kind of see how those categories build off each other. I don't have to put it in just one category. You will have multiple categories for your scripts. Okay? And this is a pre-rule function, so I'm going to return true that, yes, you run this pre-rule. And I can get really verbose in these scripts. Like some of these scripts are pretty extensive, as you can see in here, how they get set up. But I wanted to make sure that I created something that was really easy to look at and really easy to understand as we go through this. And this is something that you can run. You don't need anything for this. You don't need to go get in, get a bunch of information on this. It's everybody can grab this code, put it into their NSE script folder and run it in there, okay? So I say pre-rule, yes, I want to run this. And I have this function. This is my IP API function. This is what's actually doing the query. Okay, this is going to actually go out and query the information and create my table and return it. Okay, but I want to skip over that for just one section and drop down here to action. So action means, what do I actually do? I told you that this is a pre-rule. If I wanted this to be a host, it would say host rule equals function return true. But this is a pre-rule. So my action is now where I actually execute the function inside the script. So I'm going to return whatever this function is outputting, or I'm going to return the oops error that says something wasn't right in there. Okay? So now let's talk about how this actual function works. When you're looking at scripts, you're going to need to store some of that information and be able to access it later on in your output, or you're going to access it on building on top of that to be able to go and execute some other script here. So my output is an object that I'm going to be assigning all my table row items to. My response is what I'm actually asking the server for. So in this particular case, I'm saying HTTP get ip.co 443/JSON. So let's do this real quick, just so you can see this. Let's go up here and let's actually hit this. And let's put this as HTTPS, because that's what that port says. So if I go to my browser, this is what I get back. And you can see this is all that information. This is that JSON, that JavaScript object notation of that object that I'm getting back. And there's lots of information here, IP, the network, if it's V4 or V6, again, the location of it. Am I in the EU or not? The postal code, latitude, longitude, all sorts of things like that. So I'm going to go and take, and by calling this through the script, I put all of this data inside of the response object itself. So response now equals all that information, unless there was an error. If there was an error, I'm going to error out and say, hey, something happened. Not sure what it was, but it didn't work. But if it was good, I'm going to parse all that information, and I'm going to have that inside of my data object. Okay? So by putting that information in there, now I can go through and I can say, what are those items in there that I care about? For me, particularly in this script example, I cared about IP, network, ASN, org, location, things like that. And I also cared about EU. Now, why would I care about in the EU? Well, what we're going to look at when we run this through the CyberScope is one of the interesting things is that if you're trying to troubleshoot, say, public cloud services, if you're in an EU state, you should be redirected to an EU data center. So for like AWS, Office 365, Dropbox, any of those, you should be hitting an EU public cloud as opposed to one of the United States ones because of different requirements from data privacy requirements over there. So we want to know that if you're an EU member state or not, so that we can understand if that actually happens in there. So I showed you how this ran on here, and that's great. That's fine. You know, okay, that's pretty good information in there. But I want to actually put this into the CyberScope now, and I want to run it from the CyberScope because I want to be able to leverage this with my teammates and everybody else out into there. So when I have a script that's ready to go, and I strongly encourage you to write the script first on your computer and test it there. Once it's working, then go ahead and bring it up into here. I'm going to come up into Link Live, and I'm going to bring this into my new cyber section in here, and I have Nmap resources. Now, I've already got these scripts up into here. I've already brought them up in there, but basically all it is that you click the floating action button, say, I want to import one. I want to import either a standard Nmap or a custom discovery. We'll talk about the difference between those two here in just a second. But the standard Nmap one is the one that we care about with this script that we just wrote about the IP API information in there. So I brought that in. I actually brought, why I see two of them is because I brought them in as both standard Nmap and IP API. But I bring it in, and I'll see it, and then I can say, okay, I want to push this to those units and say push to units. And it's go ahead and it's going to push those to the units on the next time that CyberScope goes and performs any type of action against the Link Live Cloud, whether it be just a heartbeat that says, hey, I'm here, or if it's an auto test in there. So if we want to look at this on an actual CyberScope now, running Nmap, I happen to have one here. And I've got this Nmap icon up at the top now that I can look at. And I got a green dot there because I pushed a script to it. So we've got new scripts in there. And I've already loaded this up in here. But what I would normally do is I would go through and I would click that fab button again. And I would say, I'm going to add this one. And I'm going to use script, the name. And as I start typing, it would have in there. We've already preloaded all the standard Nmap ones in there. So every standard Nmap NSE script is available to you, but yours would be in here as well. So I would just start typing, and I would eventually see mine pop up in this list down in here. My IP info API, I would select it and I would go through that. But I've already gone through that process, so we're not going to go through that quite yet in here. So I've got this script in here, and what I can do is I can execute this as a one-off test, as opposed to it being part of a discovery or part of an auto test. And I can do that just by not new IP info. I have my script selected here, and I can say there's a button up at the top there that says test. So now this opens up the Nmap runner, which is going to let us execute a script. I could add in any command arguments I would need to or anything in there, but remember from our computer when we ran this on the terminal right in here, we didn't have any arguments. It was just the script itself is what we ran. So we can just go ahead and we can click on the start button. And when I click on the start button, it's going to load that NSE script and it's going to start executing it. And here you can see the results of that, which were the exact same, slightly different though. And one of the slightly different part is that I did have a target in here. So I actually ran that off in there. If I didn't want to have a target, I could say, don't include my target. That's because I was doing some testing the other night, of course, getting ready for the webinar. So if I say don't include the target and I say run it, now we should just get our pre-scan run, which is what we did. We only have the pre-scan information, and that's the exact same information, again, that we got from running it on our laptop. So we ran this as a one-off, just to be able to get some quick information about it. But you might want to attach this to an auto test because remember I talked about that in EU member state. You know, that's a true false statement in there. And maybe I want to see what happens if I run this when I'm a wireless client versus a wired client, or if I'm on this VLAN versus another VLAN. And that's where you would associate this with an auto test result. And we'd actually put it onto our auto test configurations. So I've got a profile here, this wired test in here. And I might want to look at it. I'm going to say, okay, I have all these targets in here. We're not going to go in those. We're looking at our Nmap in here. So I can go through and I can add a test target, and that test target can be Nmap. By the way, we will be allowing you to have multiple tests and multiple Nmap tests and everything in the next version coming up here. We got some enhancements. We got some actually really cool enhancements coming to the Nmap functionality on the CyberScope coming in the next code release, which I think is going to be around October timeframe, is what James told me. So look forward to some new features coming out of here with different grading colors and stuff like that. But you can see I've got my WAN IP info right here. If I click into it, I can look at it and say, okay, what is that script? I don't need a target onto it. So there's not much that I need through this. So this is just a part of my AutoTest profile, so that if I click to start on it, and remember, our AutoTest profile is either manually ran through the start stop button, or anytime we connect, we notice a link up on our Ethernet cable, we start running through that. So it's going to run through all of my tests of everything that I have in there that I've always done, but it's also going to include that Nmap test now. And of course, because it's a demonstration, it's taking longer than it normally would. I remember which port I'm plugged into here. And oh, that's why. I'm plugged into one of my ports that is purposefully damaged for doing training, where I broke one of the pairs so that you can't get more than 100 meg off of it. But as we go through and we see this, it's running. And we see here down at the bottom, now we see our cybersecurity I, our WAN IP info, which is our Nmap script. And there it is. That information was ran. That information is stored. And if we go back to Link Live and we look at our results, we should have a new result, which we do here. And one of the elements is going to be our IP info -IP API. And if we click the little arrows here, it'll give us our script information that we came out of there. So this is great for running, just to figure out, okay, some of your WAN information, some background information in there. But there's another type of script that we can run, which is called a discovery scan. And the discovery scan is unique to the CyberScope, and it's how we're building upon the NSE, the Nmap Scripting Engine capabilities of Nmap, with some of the feature functionality of the CyberScope. And it's really powerful when we're trying to figure out our pen testing, our vulnerability assessments, because it enables us to look at a lot of different information, including stuff from external APIs. So what I want to show here real quick here on this particular one is this is going to go through and it's going to look at my unified dream machine, and it's going to pull some information from that API based off of a target that I give it through the discovery scan. Okay. So if you don't know what the discovery on the cyber or on any of the NetAlly handhelds, hopefully you do, but the discovery option enables us just to sit back and listen for clients that are doing ARP requests, clients that are, generating traffic, whatever out there. And we start doing our own fingerprinting on it to try to determine what type of device it is. Is it a laptop? Is it a client device? Excuse me. Is it a printer? Is it an access point, a switch, or whatever? And we use this based off of all the profiling that we do through things like LLDP, CDP messages, stuff like that. And then we can now also add in further information from Nmap and the NSE to be able to put some really cool information in there, especially from a wireless perspective. So we've got the script here. I'm going to show you what it does first, and then we'll talk about it. So I have this script here, and it's going to go through and it's going to take a MAC address, and that MAC address is going to be queried against the API, which apparently that MAC address is not online, which is why we have multiple MAC addresses ready so that we can find one that is online or not. We might have the curse of the demos hitting us here. We do have the curse of the demos hitting us here. Well, it's saying that something's not quite right. So we figure out what's going on here. We can do -D. This is good debugging. Gives you the debug information. Unable to parse response. So what did Blake break when he wasn't supposed to be changing anything prior to a demo? I can't save it because it's on there. I didn't break anything. I don't know what it is. All right, well, We'll try it again here. We'll try it from the CyberScope, but let's look at and see what the script is supposed to be doing here, and then we'll take a look at it from the CyberScope, and then we'll see what happens in there. So this one's a little bit more intense, and like I said, that it's going through and it's looking at external sources. So again, it's still safe, it's external, it's still discovery. Our goal is that if this is a wireless device, we're going to try to pull some information from the API about what is the Unified System CDR SSI as, what channel width, what type of radio, the network name, power save, 802.11r is enabled on it or not, spatial streams, some of that really important information about those client details that we have to use a bunch of other products to try to figure out what it is, or we just have to, Google the thing and say, well, what do you support? What chipset is in there? What information is in there? So our goal is that we're trying to figure out how can we add all this information into the discovery database results that the handheld device is performing, so we have more information about a client device in there. So I've got some functions in here that just do some human conversions for BPS to human, what we look at. Looking at also trying to figure out if it's a wired device, what the human-friendly way of notating what the speeds is that it can do in there. And then in here, I have this print table function of how I'm going through and I'm trying to print all my stuff out to try to look through and come up with all this information. So you can see that this one's quite a bit more intense than the previous one. There's quite a bit more to this that we're trying to work through for the output to actually work out in there. But mainly this is just debugging stuff in here to help me out in there. For what we really care about is it's still the simple things in here, is that we're looking through different things here. I had to put in a user and a password for this. I had to have some information in here for what these different things are to, again, transfer it into human readable if I wanted to on it here. But again, it's very similar to the previous API in that we're just creating some type of request, this HTTP post. So previously it was a GET. This time we have to do a post because we have to include data. We have to include our username and our password into there, okay? And where we're hitting the login. And this is where the bug, one of the issues that comes into is that, normally this should just work just fine without any issues. Not quite sure why it's not. Worked all last night and this morning when I was doing all my testing in here. But of course, during demos, we get that. But the bug here is that when we actually put this inside of the CyberScope and run it associated with the discovery test, we would actually need to do something a little bit different in here. I couldn't just store the cookie information from the login and then immediately call this out. I actually have to write that to a file and do it, because on the CyberScope, we're going to run a bunch of these tests concurrently. We spin off different threads that run the test through. So we can have, you could have 10, 20 different Nmap scripts running on the CyberScope at one time. And that creates some race condition issues with the login information of how the Unify API works. So we'd have to write it slightly different in there. But then it's the same as before, is where we're creating our table. We got that information through our response, and we create a table and we create an output. So we have that information for us then to show in a discovery result. So previously that IP API script was just a basic one-off test, or it was a standard Nmap test. But the one that we want to look at now, and then go back far enough.
Say, Blake, real quick, pardon me, just real quick, sorry to interrupt. There was a question I wanted to just pass to you real quick. Are these scripts preloaded on NetAlly or the CyberScope, or are these default scripts on Nmap?
So all of the NSE scripts are preloaded on the CyberScope. The only ones that are not preloaded are my two scripts here that I'm showing right now. But not LD. All of these scripts are preloaded on the CyberScope. So everything that when you install Nmap on a laptop or desktop or whatever computer you're using, anything that is installed by default from Nmap is accessible to you on the CyberScope already. That was one of the things we wanted to make sure, was that we loaded a lot of the default scripts in there so that you could just start running some of these, because some of these are really good scripts, and a lot of these are what we use constantly. Like HTTP vulners is in there. There's a couple of the big name ones in here. We have the entire vulners script, which is a widely used vulnerability assessment script out there. So we did preload a lot of them. We preloaded the libraries so that you shouldn't have to do much. Like you can just hit the ground running and start looking at some of these on the CyberScope today, yes.
And then, of course, like the scripts you're doing right now, any additional ones that you create or someone else creates could be added, of course, to the CyberScope, correct?
Correct. And that's how we add them all through here adding all of ours in there by importing them up. We can also add additional libraries, Lua libraries as well, if there's a Lua library that's not there by default that we want to leverage. So we've given you the ability to use what's out of the box as well as your own custom scripts, because a lot of this is going to be custom scripts to go through and do it. Like, especially this, what we're talking about right here now, which is the discovery, the custom discovery stuff. So I brought up this UDMP as the custom discovery script here. And by bringing it as a custom discovery, what that enables me to do now is it's not so much that I just run it as a one-off or an auto test. If we flip back over to the CyberScope here, if I go into my discovery application, so the discovery, like I said, just listens and gives you a list of all the devices out there. But what I can actually do here is go into discovery settings, and I can say that I want to enable Nmap. So I want to run either an Nmap test or a custom discovery test. In my case, I want to run this custom discovery test, and I've already preset this up that it's running my UDMP client info discovery test on there. And what happens is that as the discovery is running on here, and apologize, my keyboard stays there. That's one flaw of running alpha software. As my discovery is running, it's also going to run that Nmap test on there. And let's see if we can have, if we have one. So this is where that issue pops up in here that I didn't fix my API key issue. Let's refresh the discovery and see what happens. Hopefully we can get one result to show up. Otherwise, I'll take one demo failure, I guess. Everything else is working fine in there. So as it pulls up and it collects all this information there, then what it's going to do is it's going to start queuing Nmap discovery tests to be ran against these devices. And it's going to start querying my API to figure out what's going on in there. It's going to start adding that information in there. So let's see if we get one in here. That one's not ran yet. That one's still collecting. So while that's running, I'll point out one other thing that I didn't mention earlier. So in this case, with these scripts, I don't really care about the warnings or errors or anything on them because these are just data analysis, data collections on there. But something that I can actually do is if I go into the Nmap tests here and I look at these things, I can also put in here that the result must contain or the result must not contain. And then I can throw errors off of that. So, you know, obviously, like, we don't want anything to say warning. So what if that result came back with warning? You know, warning is something that was bad anyways, you know, like a host was not up or something like that. I can say the result must not contain it. But if it does contain it, what type of result grade do you want to give? A warning or an error? And what that's going to do is that's going to change that color of that icon on the left-hand side here. That's going to change it to be red or yellow or green based off of whatever the results information comes back as, just like what we have on all our other ones. And I'm not quite sure why that script's not, why she's not really executing what she's supposed to be doing here at the moment. Like I said, that's what happens on demos, right, Brad?
Yeah. Yeah, you can practice all you want, and then when you go live, sometimes, not always, you get little snafus like this.
Not sure why that's not giving me information. That's really bumming me out that that's not giving you information. Basically, what I would end up coming back with is, you know, we should have seen, like I have in the table up here, we should see all this cool information come back about the client device. And I'm going to actually look on my iPad here real quick and see. Any other questions while I try to find an online client that will actually give me information?
Not right now, but one thing we could also offer too, Blake, is perhaps when we send out the follow-up email, you know, if later, of course, it'll work just fine, right? So perhaps we could even create you know, have a link that would show that executing later, you know, so again, that way you can move on. Does that work for you, Blake?
Yeah, that certainly does too. I mean, we're coming up at the top of what we had for content.
Yeah, it'll work the minute the webinar is over, right? I mean, you know, it'll work like immediately. So that's just sometimes how Murphy's Law works. But we could just do that. I'll make sure to include that in the follow-up email so folks can rewatch the webinar, of course, and actually see it executing on the CyberScope, if that works for you, Blake.
Yes, that does. Because I'm actually getting errors when I hit the web browser on the UDMP. So I think actually I have something else going on, but.
But to answer your question, Blake, there are no other questions that are coming in. So I don't know if you want to move on or maybe just talk about some other general capabilities of CyberScope and Nmap or so forth. So,
yeah. So yes. So ultimately, what we should have there, we should be able to go through and we should see that this information is in there. And I do have this as a previous result because we do know that it works. So let's go and let's look at our results here. So basically, what we would see again is we'd end up seeing that information inside of our discovery results in there. So as I go through on this, if I upload this discovery result into Link Live, and actually hit the button, save to analysis files. See, they're uploading. So it's uploading that information there. All that information then is going to be accessible as well with the client device saying what those things are that is in there. So if I go into the topology here, and this is where it really starts to become powerful with the addition of using on the CyberScope, is that now I've got a visual viewpoint of all of those information. So if I were to have these vulnerability assessment scripts set up where they're giving me the different warning informations, so I would, generally speaking, when I'm going to do this, one of the things I would do here on my discovery settings, when I'm starting to leverage now the CyberScope for my vulnerability assessments, is I'm really starting to turn off quite a few of the other testing and only leaving that I have my Nmap testings enabled in there for giving me my warning messages and things like that. Because then what ends up happening is that inside of this topology here, I can quickly and easily start to see like what was an error. So if I zoom in, not zoom out, if I zoom in on some of these things in here, I start to see, okay, all these devices, they're seeing that they're attached to these different access points. Some of them have their name, some of them don't, depending on the information, again, that we got through running on our tests in there. But if I look at, specific client devices and look into them, I can start to see that information about, what are my risks, what are those different clients that I need to go through and start considering, okay, I should start looking at these devices because these particular devices are problematic in there. And I can start looking at it and I say, okay, problems, do I have any warnings? Do I have, maybe I only care about ones that are connected to specific SSIDs, and I can start kind of building that attack vector list of, okay, what could, how vulnerable am I? Because that's always the question with vulnerability assessments, is that it's how vulnerable am I to somebody bringing in a laptop? Again, we'll pick on Brad here. If Brad brings in a laptop that has some kind of command control protocol on it, when he attaches to this access point, and it only works off of a layer 2 broadcast, and I have broadcast layer 2 traffic enabled peer-to-peer on my infrastructure, okay, this is the risk. These are the devices that Brad could be infecting by being on that device or on that access point. Anybody over here is not vulnerable. So bringing all this information through by collecting the information inside of our scripts, leveraging additional data collections through external APIs, building profiles about the types of client devices, starts to enable us to figure out not only how vulnerable we are, but also what is the risk that is going to be to other potential devices that are out there connected onto our network. And we're going to talk about some of this more in detail as well on our next webinar, where what we're going to be focusing on is less on, specifically on like this technical scripting and building this, but looking at it as to how are we marrying that relationship between the security engineer and the network engineer or the technical engineer, whoever the tech that's on site, and being able to empower them to collect all this information to kind of try to break down the walls, get rid of some of those silos that we have between security and between network engineering, and try to make us, one big happy family that's working through all of this. So we talked briefly about the CyberScope. Hopefully You've seen some of the literature on this already about there. It is about doing the assessments, analysis, reporting, that one tool. Everything's in there. Leveraging those NSE, the Nmap scripting engines, to be able to become even more powerful in your data collections and figuring out all the information in there. Again, like, we're building this around a workflow, and that's what we're going to talk about in our next webinar. Is how do we create this entire workflow for our teams to work together, come up with all the data, be able to provide all that for data analysis, and come up with a solution that says, okay, yeah, here's what our risks are, or no, we're not vulnerable to this new attack that's out there because we've ran that test against all of our client devices, all of our network devices, and we don't have that vulnerability. That's one of the big important things about doing this vulnerability assessments, is leveraging some of those CVE tests, which are through the Vulner's NSE script library. All right, so we are at the top of the hour, or just about. We got 3 minutes left. If there's, we'll open it up for questions here. Again, like Brad said, I'll try to get a quick little recording of the script actually working, and we'll get that sent out. We'll get that out to you. I apologize for that demo not working. I always hate it when demos don't work. But again, you will receive a copy of the deck, and we've got this recorded, so you'll be able to watch it again. Questions, feel free to reach out to me, reach out to sales at NetAlly, get a hold of your account manager if your partner or if you have a named account manager for the team. Otherwise, make sure that you're checking out that link there again, cyberscope.netally.com, for all of our other webinars that we'll be doing or have already done, because we've got quite a few out there. We've got some really good ones from the launch back at the RSA conference this year with James and his guests that he had on there. Yeah, so that's it. Any last questions?
There were no additional questions. And Blake, I did want to thank you for this wonderful webinar. Everybody that attended likewise. There will be recordings sent out of this webinar, and we'll try to get a link from Blake actually showing that script running. We'll try to include that as well, so you folks can actually see that executing. And Blake did allude to the next webinar in the series, the convergence of cybersecurity and network operations teams. He'll build on everything he talked about so far, both in this webinar and the 3 blogs we referenced earlier. So make sure you attend that on October 5th. Register to attend that on October 5th. And again, we hope this has been helpful, and it's beginning to really show the power of CyberScope in terms of its capabilities. And when you add Nmap to that, how you can really broaden your visibility at the site access layer and make you much more robust your cybersecurity posture. Thank you again, everyone. Have a great day.